Good morning. We today are working on Module 5, Lesson 18. When you come into office hours, I want you to say the word sunshine. So when you come in, the first thing that you're going to do is you're going to type the word sunshine in the chat. As you're working through this, you're either doing it on a sheet of paper and then uploading those photos straight into the Google Doc. It's really easy for us to see it then. Or you are typing it directly in, but you need to make sure that your work is shown. So you should have paper and a pencil along with it pulled up in YouTube, which you have right now, and the Google Doc, which is on Google Classroom. Have all of those up, watch the entire video. We can see how long you're watching these videos. And then what you are going to do is work through the packet at the speed that it says, and then come to office hours to ask clarifying questions and to check your work with us. Alrighty, this is a good lesson. I will see you all in office hours. Good morning. You should be looking at Module 5, Lesson 18, and at the Fluency portion right now. So again, remembering how we divide with fractions. Let's look at number 1. We have 1/2 divided by 2. So if we are drawing this as a tape diagram, we have 1/2. Okay, so I've split my 1 into half. Here would be my 1/2. And I'm dividing it into 2. So that means I'm going to split this into 2 and this into 2. Here's where it overlaps. So we now have 1/4. If I were to skip over and look at number 23 over here, I have a whole number. I have 4. 1, 2, 3, 4. So my whole thing is 4. And I'm dividing it into 1/4. So that means in each one I'm saying, okay, there's 4. That's 3. Oops, let's try that again. There's 4. Imagine that it was split a little bit more evenly, but I have 4. I'm splitting them all into 1/4. How many pieces do I have? I have 16. Pause the video now and work through this page. When you come to office hours, I'm going to ask you a random one, and that is how I'm going to know that you've completed this page. You now have your Thrive Point Challenge. Set a timer for 2 minutes, see how many you can complete. If you show us this in office hours, you will get extra Thrive Points if you have completed it. Moving on, we are now looking at the application problem. I'm going to make it a little bit lower so that we can see it. How many 2-inch cubes are needed to build a rectangular prism that measures 10 inches by 14 inches by 6 inches? I want you to start by doing a plan of attack and pause the video here while you work through that. Okay, so you should have everything that you know and everything that you need. Now, typically we talk about 1-inch cubes. So you should have drawn a picture of a rectangular prism and said, okay, it's telling me it's 10 by 14 by 6, all in inches. That's my unit. It wants to know how many 2-inch cubes are needed. So that means the cube is bigger than what we're normally talking about. There are 2 different ways to try this. What I want you to do is pause the video and try one of those ways and see if you can figure out how many cubes would be needed in order to fill up this spot. So pause now. All right, so when I'm looking at it, the 2 different ways. So let's say we're going to show number 1, and then I'm going to show you number 2. And maybe one of these ways is how you did it. So I'm thinking, okay, here's the whole thing. So I need to say 10 times 14 times 6. The only reason that I'm doing that is to find the area of the whole thing based on the dimensions that it already has showed me. When you did that math, you would have gotten 840 inches cubed. Okay, so that's the whole thing. And I need to figure out, now if it was 1-inch cubes, I would just say, well, that's 1 times 1 times 1, which is 1. So how many cubes would I need? 840. But it's talking about 2-inch cubes. So I'm thinking that's 2 by 2 by 2. It wants to know if little cubes were filling up the whole thing and they were all 2 by 2 by 2. Well, that right there gives me 8 inches cubed. So if I'm trying to figure out how many with an area of 8 inches, which is this whole inside here, this is 8 inches cubed, how many of those can fit inside? So I'm going to take it and say, well, 840 divided by 8. Tell me what you get. Tell me how many 2-inch cubes are needed. The other way is to think of it and say, okay, well, 10 inches would be 10 cubes if they were all 1-inch cubes. But this is telling me 2-inch cubes. That means half the size. So instead of saying the 10 times 14 times 6, I'm going to say, well, if it's a 2-inch cube, that means it's only 5. And instead of 14 with a 2-inch cube, it's only 7. And with a 2-inch cube, or half, it's only 3. And I'm going to multiply right there. You should get the same answer for both of them. And when you come into office hours, tell us what you got for that application problem. How many cubes are needed in order to fill it up? Go ahead and pause so that you can finish taking those notes, get an answer, and then we are moving into concept development. All right, we are now looking at the concept development. It says draw a rhombus and articulate the definition. That's what we're going to focus on. Now, a rhombus is a quadrilateral with all sides of equal length. We know that a quadrilateral means it has 4 sides. It says all of the sides need to have equal length. Well, you know what? That really sounds like a square. It sounds like a square. But in a square, let me make a better square. But in a square, all of the angles would be 90 degrees. But all of the sides here are equal length. We use these markings to show that that's the same length. They all have 1 dash through it, so they're all the same length. We're able to do that and to show the length without actually measuring it. Okay, well, so then wouldn't this just be a square? It's a quadrilateral, yes. They all have sides of equal length, yes. But a rhombus does not need to have 90-degree angles. The angles can be anything. So a rhombus can have sides of equal length. So if I use these dots, I'm going to say 1, 2, 3, 4 going across. 1, 2, 3, 4 going across. Imagine those lines were straight. Now, I'm telling you, based on these ticks, they're all the same length. But we know that these angles, these would be the same angle, and this would be the same angle. These green ones would be acute angles, and our pink ones would be obtuse. Now, let's see if this is a rhombus. Is it a quadrilateral? Yes. And do all of the sides have equal length? Yes. That's a rhombus right there. Now, if you were to look at these measurements of the angles that I just talked about, you would realize, okay, well, these are going to equal 180. You have 1 acute and 1 obtuse. And then these are going to equal 180. 1 acute and 1 obtuse. Moving on to the next one. You do not need to measure and label the angles. All that we are doing, you should have written exactly what I have. I want to see the markings showing the angles or the 90 degrees, and the markings showing the sides are the same. And you are moving on to the next page. Now we are looking at a rectangle. Again, I'm going to move this down so that we can see it a little bit bigger. Okay. Now, we've done rectangles before. So let's draw a rectangle. Okay. It's a quadrilateral, so 4 sides, we got that, with 4 right angles. That means 90 degrees. Well, in a rectangle, they're always going to be 90-degree angles. Now, if we were to mark our sides, these are the same sides right here. And then these are parallel to each other, and they are equal. I show that in those markings. The ones with 2 are the ones that are equal to each other. This shows a rectangle. So a rectangle has to have that 90-degree angle. It is still a quadrilateral. If we were to look at the diagonals that go across right here, they are equal as they break each other apart. The diagonals are equal and they bisect each other. They make each one turn into 2. When you do over here, if I were to draw another rhombus that looks like this, and we were to draw diagonals that go through it, they are not equal. The diagonals are not the same length. They are perpendicular bisectors. They perpendicularly cross each other. Okay, you are now moving into your problem set. I will again move it lower so that you can see. Now, it wants a rhombus with no right angles. I'm going to use these lines to help us draw it. That way we don't even need to measure it. Okay, so a rhombus, if we go back and look at our definition, it's a quadrilateral, all sides are equal. Okay, it wants no right angles. So I'm thinking, I'm going to go like this. That's 2 right there. That's 2 right there. I know that they're the same. Here's 2 and here's 2. So I know all of my sides are the same. And none of them are right angles. None of them are 90 degrees. We have obtuse angles right here. We have acute angles less than 90 right here. So the attribute listed is that all 4 sides are the same and no right angles. That's what you're going to write next to it. So you've drawn it. All 4 are equal sides. No right angles. Moving right along, B now asks us for a rectangle with not all equal sides. Okay, so I could say, maybe I go like this, maybe I go like this. They are not all equal sides. Now the way I'm going to show that, since I don't have a ruler, those are the same and those are the same. I know that it is a rectangle because I have 4 sides that are equal. 4 sides are equal. And they are all 90 degrees. 90-degree angles. It has to be for a rectangle or a square. Now it wants a rhombus with 1 right angle. So as I'm drawing this, I'm thinking, okay, rhombus means it needs to have 4 equal sides. If it has to have a right angle, look what that's going to look like. It says with 1 right angle, but it's okay if it has more than 1 right angle. This is a rhombus. Then we have a rectangle with all the sides equal. A rectangle with all the sides equal. Well, if all of the sides are equal, you're going to realize that that is a square. Make sure you mark the 90-degree angles. Make sure you mark the lengths and how they are equal. Okay, we are skipping number 2. It might not even be on your packet. And you're moving straight into number 4. Now, what are the properties for number 4 that are shared by all of the rhombuses we worked with? Okay, we talked about the fact that they're all quadrilaterals. So we have 4 straight sides. That's one that they all had. What else did they have? You are going to finish the rest of 4 answering all of these questions, and that is what you are going to show us when you come into office hours. Then you are going to move on to your exit ticket. When you write your exit ticket, you need to be able to tell me what attributes make it a rhombus and what make it a rectangle. What are the things you have to have in order for it to be that shape? Nice job with this. Go ahead and finish it up. Have all of your notes ready to go, and then meet us at office hours.